It has long been the goal of airplane designers to produce a plane that can fly long distances at high speeds, carry lots of cargo, and take off and land like a helicopter. Today, that plane, Bell Boeing V-22 Osprey, is one of the most recognizable aircrafts in the United States Air Force. Its use of tilt rotor, the Osprey can take off and land like a helicopter, but also fly like a turboprop plane. It is the first tilt rotor aircraft to be used by a military force. Conventional military planes have a severe flaw because they can't take off without a long runway. This runway is an easy mark that the enemies can locate and destroy. The Osprey, however, is immune to this problem because of its ability to take off in a vertical position. The US military researched and developed several types of tilt-rotor aircraft throughout the Cold War, only to eventually scrap the projects. In the end, the Osprey represents the culmination of the technological advancements that have been made. Having served for almost 30 years, the V-22 Osprey has revolutionized military and civilian missions for the United States Marine Corps, United States Air Force, and now the United States Navy. Want to know more about it? Stay with us to the end of the video. There's a lot of information to be revealed. The multi-purpose fighter plane can do anything. Bell Helicopter and Boeing Rotorcraft Systems collaborated to build the Bell Boeing V-22 Osprey, a one-of-a-kind multi-mission fighter plane. The maiden flight occurred on March 19, 1989 and went into operation on June 13, 2007. The vertical capabilities of a standard helicopter were included in the design of this craft, along with the performance and range capabilities of a turboprop plane. Due to its fixed wing and rotary wing flexibility, the V-22 is acknowledged for its vertical landing and takeoff, or VTOL, and shorter takeoff and landing, or STOL skills. The V-22 is the go-to plane for demanding missions because of its adaptability and durability. The V-22 helps with military planning, such as moving personnel and supplies, as well as engaging in direct battle, rescue operations, and international aid. In addition, it was designed to receive fuel while in flight, significantly increasing the aircraft's capability and opening the door to more extended missions. The aircraft's flexible rotors and movable wings enable compact storage and efficient use of available space upon touchdown. The importance of progress and development. After the 1980 collapse of Operation Eagle Claw to save American hostages in Iran, the US military realized it needed a special variant of an airplane that would not only ascend and descend vertically, but also transport combat soldiers and do so at speed. The V-22 plane process was started in 1981 by the United States Department of Defense and the United States Army. The execution of an amphibious landing has always been the primary objective of the United States Marine Corps. As a result, the military rapidly developed an interest in the project, which includes airborne options with solid mobility and distance-enabled fast dispersion. The Navy management and the Department of Defense criticized the tilt-rotor technology, but legislative pressure ultimately won. Boeing Vertol, Grumman, Lockheed, and Westland were the four companies involved. On February 17, 1983, Bell and Boeing Vertol submitted an idea for an updated model of the Bell XV-15 prototype. Due to only one bid being presented, a contract for the planning phase was issued on April 26, 1983. On January 15, 1985, and the designation of the V-22 Osprey aircraft was announced. By March of that year, the first 6 prototypes were being built, and Boeing Vertol had been enlarged to accommodate this production. In May of 1988, the world was introduced to the very first V-22. The production of the world's first tilt-rotor aircraft. With a turbo transmission and engine gear installed on each wing, the Osprey marks the first manufacturing tilt-rotor aircraft. Regarding the FAA's classification system, this plane fits the bill for a driven lift aircraft. With the propellers up and the rotors down, it functions like a conventional helicopter during both landing and takeoff. While in the sky, the nacelles may be rotated forward 90 degrees within as little as 12 seconds to allow for horizontal flying, transforming the V-22 into a more effective, faster turboprop aircraft. The nacelles can be tipped forward up to 45 degrees, allowing for an STOL or short takeoff, moving takeoff and landing potential. When in flight mode, the V-22 is compared to the C-130 by operators for its handling and speed. The proprietary shafts and 43% of the structure are composite materials. The V-22's rotors can be folded in 90 seconds and the wing can rotate such that it is front to back aligned with the body. 75% of operations use a fixed wing flight, which lessens maintenance and operating costs. This fixed-wing trip is higher than traditional helicopter flights, providing greater management and control through extended-range line-of-sight transmissions. Unfortunately, the V-22's engines release a great deal of heat during operation, which has the propensity to melt the decks and coverings of naval aircraft carriers. NavAir came up with a quick fix of movable thermal applications placed underneath the engines, but ultimately concluded that the only permanent alternative would be to remodel the decks with flame-retardant covering thermal control boundaries and modifications to the plane's composition. Development budget. In 1986, $2.5 billion was set aside for its completion. By 1988, that number had grown to $30 billion. Roughly $27 billion was already budgeted by 2008, with a similar amount expected to be spent by the time the planes were acquired. Maintenance and repairs accounted for nearly 61% of the total cost of operation increase between 2008 and 2011. V-22 Osprey accident rate. This plane is not entirely risk-free. To put it bluntly, many uninformed claims regarding the V-22 are spread. There were indeed a lot of hiccups with the design and testing phases, along with several deadly incidents. But that's part for the course with brand new aircrafts, not for a new airplane category, which sadly had to discover some things the hard way. Pilots who have switched to the Osprey from those other FW or RW systems in the Marines or the United States Air Force don't see it as a risky aircraft. If someone from the surrounding world brings up the unsettled V-22, most people in the community react by rolling their eyes. There have been 13 hull loss crashes involving the V-22 Osprey, resulting in 51 deaths. Between 1991 and 2000, 30 people lost their lives in 4 separate mishaps during training. There have been 8 fatal collisions involving the V-22 since it entered service in 2007, along with several other incidents. Concern has arisen regarding the aircraft's reliability because of its accident record. After fixing the problems that caused the crashes during its development, the Osprey was put into service and has been fairly safe. Since then, the aircraft has logged hundreds of flight hours in harsh, inhospitable conditions, and it has performed very well. At this point, it is considered one of the safest rotorcrafts in the Marine Corps arsenal. Engines and engineering objects. Dual Rolls-Royce AE1107C turboprop engines provide the plane with a full load output of 4,586 kilowatts. The engines have a Systron Donner fire suppression system, a standby analog electronically controlled technology, and full authority digital electronic control, or FADEC. Single engine control is possible because of the transmission's connecting shaft. Putting up an AI research infrared radiation suppression equipment on the nacelles close to the engine output reduces the plane's heat signature. The complete rotor, gearbox and turbine nacelles may rotate over 90 degrees ahead for forward travel and through 7 degrees 30 feet aft for inclined landings and takeoffs. The ATK AN/AAR-47 Advanced Radar is a component of the airplane's electronic warfare package. It comprises 4 electro-optical detectors, a photomultiplier tube, a transmission baseband processor, and a cockpit screen. There are 60 sets of chaff and flares in the aircraft's launchers and radar and infrared danger alert system. The V-22 Osprey can reach up to 565 km per hour with a cruising speed of 510 km per hour. Why is it being utilized this way? With the speed and range of a turboprop, the maneuverability of a helicopter, the Osprey has changed the battle landscape for the United States military. The aircraft has allowed them to get troops into areas twice as fast and 5 times farther than the conventional helicopter. The Osprey performed extremely well in the Iraq and Afghanistan wars. Over that time, the Osprey fleets have managed to log 600,000 flight hours. During this period, it has managed an accident rate as low as other Marine Corps aircraft. Early on, the Marine Corps saw the value of the Osprey and provided the time and manpower needed to work out the kinks in its development. Recently, the US Navy has decided to replace their aging C-2 Greyhound with the Osprey. This will help them to better transport people and heavy cargo to and from aircraft carriers and can also make the same type of transport to surface ships more quickly and effectively. The Osprey's ability to fly like an airplane but land like a helicopter has freed the military from the limited range of the conventional helicopter. Its heavy lift capability along with its range has fulfilled the US military's need to transport its troops and cargo quickly to places that were once difficult to access. Thank you for watching. If you have any questions, let us know in the comment section. Also, at last, give a like to this video and I'll see you soon.